IG Nobel 2023. Necrorobotics, anchovy sexual activity and other peculiar research. On the night from Thursday to Friday at Harvard University, the ceremony of awarding the IG Nobel Prize, also known as the Anti-Nobel Prize, took place at Harvard University, i.e. prizes awarded for scientific works that, first make you laugh, then make you think. These are the humorous equivalents of the Nobel Prizes. This year, the awards included research on the use of dead spiders to catch objects, works describing the practice of stone licking by geologists and the development of an intelligent latrine identifying people based on a photo of the anus. Unlike the prestigious Nobel Prizes that will be awarded next month, the IG Nobel Prizes honor non-obvious areas of research that are initially laugh-out-loud funny, but once the hilarity wears off, become thought-provoking and scientifically valuable, and are published in peer-reviewed journals Scientific. The awards are granted by the journal, Annal of Improbable Research, and this year they were presented for the 33rd time. Each winning research team, in addition to a commemorative diploma, also received a substantial amount of 10 trillion United States dollars printed by the Zimbabwean government. Of course, these notes are almost worthless. The satirical nature of the awards also aims to popularize science by showing the funny side of a researcher's work. IG Nobels are, as it were, an introduction to the real Nobel Prizes. The awards at the gala are presented by real Nobel Prize winners, although these awards are treated with a pinch of salt. During the gala, fun is the most important thing. The IG Nobel Prize in Literature went to a team researching the phenomenon of jamais vu, which is the opposite of déjà vu. This is a situation in which we consider a known phenomenon or thing to be new. Team member Akira O'Connor, a neuroscientist at the University of St. Andrews, explained that it's possible to recreate this sensation in the lab by having subjects repeat one word many times until the word begins to sound foreign. Jamais vu may be a symptom of epilepsy or migraine. To generate the feeling of jamais vu, the researchers asked volunteers to write the same words over and over again until they felt weird, which usually occurred after 30 repetitions, or about 1 minute. Study participants said they had the impression that words lost their meaning the longer they looked at him, or that a familiar word suddenly seemed strange or inappropriate. Those who reported experiencing déjà vu in their daily lives were significantly more likely to report experiencing jamais vu, suggesting a correlation between the phenomena. The authors of the papers hope that the award will draw more attention to research on jamais vu and related phenomena. This year's Public Health Award went to Stanford University urologist Sung-Min Park for inventing a smart latrine that can monitor a person's health by analyzing their urine and stool. The toilet checks urine for signs of infection, diabetes and other diseases. In addition, the computer uses a video camera to calculate the speed and amount of urine excreted. Additional sensors can identify a given person based on the unique features of his anus, which the vision system takes photos of. This type of toilet enables monitoring and quick analysis of substances excreted by humans. The scientist also thought about the coronavirus. A COVID-19 specific version could be equipped with modules to collect stool samples and conduct rapid tests for the virus. Test results could be transferred to the user's smartphone within minutes. Other diseases could also be examined in such a toilet. The Chemistry, Geology Prize was awarded to Jan Zalasiewicz from the University of Leicester in the UK. The jury appreciated his essay in which he referred to the practice of licking rocks. It turns out that this is a pretty good way to check whether a stone is a stone or even a piece of fossilized bone. Fossilized bones, he says, stick to the tongue. And grinding the stone between the teeth can help determine the grain size, and therefore whether the rock contains clay or silt. Wetting the surface allows the textures of fossils and minerals to clearly stand out. According to Zalasiewicz, this practice may date back to the 18th century mining engineer, surveyor and self-proclaimed mineralogist Giovanni Arduino. In a letter to Antonio Vallisneri, a professor at the University of Padua, Arduino described all the rocks, minerals and fossils in the Agno Valley, including useful notes. He wrote, for example, that burnt fossilized shells and pieces of coal were bitter and diuretic, and that the water flowing from a layer rich in marcasite and carbon has a sour spicy taste, which Arduino compared to the acidity of wine. However, Zalasiewicz admitted, we do it to support the sense of sight, not taste, because a wet surface reveals mineral particles better than a dry one. The Mechanical Engineering Award went to a team from Rice University for reviving dead spiders for use as mechanical gripping tools. One day, Fei Yap noticed a dead, curled-up spider in the laboratory corridor and learned that spiders curl up when they die. This is due to their body structure and their internal hydraulics. The scientist thought it would be cool to use the bodies of dead spiders as tiny grippers to lift and maneuver small electronic parts, and such a system was created. Researchers transformed a dead spider into a capture tool, essentially starting a new area of research they cheekily called Necrorobotics. Unlike humans and other mammals, which move their limbs by synchronizing opposing muscles, Spiders use hydraulics to move. The cephalothorax, i.e. the prosoma, is responsible for everything. And in its action it resembles a bellows filled with fluid. When it contracts, it sends a body fluid called hemolymph to the limbs, forcing them to straighten. When the pressure is released, the legs contract. It's all about the mechanism of increasing and decreasing the hemolymph pressure in their legs. Therefore, when the spider dies, this mechanism stops working and its body curls up into a ball. All they had to do was insert a needle into the dead spider's prosoma and attach it to the body with glue to create an airtight seal. The whole process took 10 minutes. The other end of the needle was attached to the syringe. Applying tiny blasts of air increased the pressure in the prosome and immediately activated the dead spider's legs, causing them to open. The expansion of the chamber caused the legs to refold. The team tested the gripper on various objects. For example, they used it to remove a wire on an electrical board to disconnect an LED. In tests, the spider gripper could lift objects that exceeded the spider's body weight, exerting a maximum gripping force of 0.35 millinewtons. The medicine prize went to a team of scientists who examined human corpses, specifically their nostrils, to check whether each of them contained the same number of hairs. The information we needed wasn't available in anatomy textbooks, so we decided to find out on our own, said Natasha Masinkovska of the University of California, Irvine, who led the study. The researchers wanted to learn more about alopecia areata, a condition characterized by hair loss on the scalp, eyelashes, eyebrows and nostrils. Researchers have noted that many people with the condition are more susceptible to upper respiratory infections, allergies and dryness because the condition also causes hair loss in the nostrils. They also realized that no one had actually looked at counting the average number of nose hairs in people. A first step in assessing the impact that their absence might have on patients' quality of life. Using 20 cadavers, 10 men and 10 women, from the University of California, Irvine Medical School. The researchers counted the hairs in each nostril and used a tape measure to determine their height. The results showed that the average number of nose hairs per nostril is between 120 and 122. In the field of communication, the prize was awarded for studying the mental activity of people who are experts at talking backwards. Reverse speech is the extraordinary ability to quickly reverse words, pseudo-words, and even sentences, which requires changing the order of phonemes while maintaining their identity, they wrote in their 2020 paper. The research team believed this presented a new opportunity to learn more about how the brain processes phoneme sequencing. For their experiments, the team recruited 2 men who were experts in speaking backwards. They both used Spanish because it is a particularly suitable language due to the fact that phonemes always retain the same sound regardless of their position and surrounding segments. For comparison, a control group of 18 other men was also recruited. All participants were subjected to general cognitive and memory tasks, as well as language tasks, including backward-speaking tasks. They found that the two reverse speech experts showed a clear behavioral advantage in word reversal that was unrelated to their memory skills. Brain imaging of these two men showed increased gray matter volume and increased functional connectivity, white matter, in key parts of the brain related to language. It's a small sample size, but the conclusions are consistent with previous research by experts in the field of simultaneous interpreting, which suggests that language-related neuroplastic adaptations can emerge even from unconventional forms of language knowledge, even those that are not publicly practiced in real life. The Ig Nobel Prize in Nutrition was awarded for experiments to determine how electrified chopsticks and drinking straws could change the taste of food. Our sense of taste is very important. The point is not only to enjoy our favorite foods and drinks, but above all to help us avoid food that has gone bad and could pose a risk to us. In their research, Home Miyashita and Hiromi Nakamura proposed enhancing our taste using electrical stimulation. Scientists have lamented the fact that we only have taste buds on the tongue, while a catfish has taste buds all over its body, making it a floating tongue. Japanese researchers inserted negative and positive electrodes into two different straws, then placed each straw into one of two cups filled with a drink containing an electrolyte. When the user drinks, they complete the circuit and the straw delivers an electrical stimulus to the mouth, producing an electric taste. They did the same with food, inserting positive and negative electrodes and using chopsticks as a user interface instead of straws. Apparently the ability to feel this electrical taste depends on voltage, so the authors added a voltage regulation function. The goal of our system is to obtain a new layer of the tongue that can detect flavors that we could not sense before, they concluded. The award in the field of education was awarded for research on boredom among teachers and students. Boredom in class is ubiquitous, as evidenced by dozing off, staring out the window, or scribbling in notebooks, and this does not bode well for education, as bored students may be less motivated and perform poorly academically. But teachers can also get bored, especially if they teach the same material to apathetic students year after year. A team of researchers examined how a bored teacher can influence students' boredom. A total of 437 students and 17 teachers from 2 secondary schools in Hong Kong participated in the study. All subjects were asked to keep a diary for 2 weeks and record their level of boredom. Students were also asked to rate their teachers' level of boredom and motivation each day in class. Researchers found that, indeed, when teachers were bored, students were less motivated to learn. In subsequent research, researchers wanted to determine whether simply expecting a lecture or class to be boring would become a kind of self-fulfilling prophecy. The research concerned university lectures and confirmed that the more students expected the lecture to be boring, the more bored they became later. The Psychology Prize was awarded, for street experiments to see how many passers-by will stop to look up when they see strangers looking up. Psychologist Stanley Milgram conducted a study on crowd formation, specifically examining the pull of crowds of different sizes. He used a 50-meter stretch of a busy sidewalk in New York as a laboratory. When a signal was transmitted from the 6th floor window of an office building across the street, a designated stimulus crowd, consisting of 1, 2, 3, 4, 5, 10, or 15 people, entered the observation area. These people would stop, look up at the window for a full minute, and then be signaled to disperse. The experiment was repeated several times and filmed for later analysis to see how many of the 1,425 passing pedestrians changed their behavior by either stopping and looking up or looking up without breaking stride. They found that the size of the stimulating crowd was a key factor influencing the number of passers-by who stopped. When just one person looked up, just 4% of passers-by stopped and looked up as well, compared to 40% who stopped when the stimulus crowd numbered 15 people. The same was true for passers-by who looked up without stopping. 42% looked up when there was one person in the stimulating crowd, compared to 86% when there were 15 people in the crowd. This contradicts the existing model that assumes that the critical factor will be the number of people who can join the group, in this case, pedestrians, rather than the size of the stimulating crowd. Milgram and his co-authors emphasized, however, that the nature of the stimulus, what the stimulus crowd looked at, also influences these numbers. Their experimental scene wasn't particularly interesting and therefore didn't have much impact. However, if there was an acrobat in the window, it would probably generate interest for longer, causing the crowd to quickly grow. The Physics Prize was awarded, for measuring the extent to which ocean mixing influences the sexual activity of anchovies. Ocean mixing is a key area of research in climate science because it affects water properties such as temperature, salinity, oxygenation and nutrient loads. Winds and tides are the main sources of energy needed to mix the oceans on a global scale, but some scientists suggest that floating organisms, zooplankton. Fish and marine mammals may also be a significant source of energy for water mixing, but on a more regional scale. However, this type of turbulence is quite difficult to capture, and previous research has suggested that the mixing efficiency of this activity would be too low to be significant. Scientists have shown that living organisms can effectively mix ocean water. Data collected over 2 weeks during the summer of 2018 revealed intense turbulence. It turned out that the culprit was European anchovies. Although the team did not directly detect the presence of fish, the acoustic data was consistent with fish aggregations, and there were high concentrations of anchovy eggs during daily morning plankton netting. These studies, according to their authors, provided convincing evidence that fish can generate intense turbulence for extended periods of time.